Hello everyone! Welcome to the Ultrasonic Kit for Arduino tutorial series. Today we'll get to know a new device, a relay. A relay is an electromechanical switch that is activated by electricity and uses magnetism to turn the switch either on or off. The purpose of a relay is to switch high-power items that can draw too much current to safely come in contact with the switch itself, or to enable you to run high currents through one wire and connect and disconnect them with low current through another wire. Basically, a relay is a switch that keeps you away from dangerous amounts of power, or lets you use smaller wires to run things. Today we'll use it for a switch to control the LED on and off. It might be a little bit difficult to understand, so you may better focus. First, let's look at the experimental phenomenon. When we power the circuit, the normally open contact is closed and the LED connected lights up. 1 second later, the contact is open and the LED goes out. Then, 1 second later, it lights up. The LED is turned on and off repeatedly and does not stop until the circuit is powered off. At the instant of LED lighting up and going out, you may hear a click sound, which is that of the relay opening and closing. Now let's take a look at the components. The SunFounder Uno board, a breadboard, some jumper wires, a USB cable, a relay. In this experiment, we use an electromagnetic relay. See the picture here. A is an electromagnet, B armature, C spring, D moving contact, and E fixed contacts. There are two fixed contacts, a normally closed and a normally open. When the coil is not energized, the normally open contact is the one that is off, while the normally closed one is the other that is on. Add a certain voltage to the coil and some currents will pass through the coil, thus generating the electromagnetic effect. So, the armature overcomes the tension of the spring and is attracted to the core, thus closing the moving contact of the armature and the normally open contact. Or you may say, releasing the former and the normally closed contact. After the coil is de-energized, the electromagnetic force disappears and the armature moves back to the original position, releasing the moving contact and normally closed contact. The closing and releasing of the contacts results in power on and off of the circuit. The schematic diagram of the relay is shown here. Now continue the list. A 220 ohm resistor, a 1K resistor, a red LED, a diode. A diode allows an electric current to pass in one direction, called the diode's forward direction, while blocking current in the opposite direction, the reverse direction, thus protecting other devices in the circuit from a large reverse current at the instant of coil de-energizing. And an NPN, or transistor. NPN consists of a layer of p-doped semiconductor, the base, between two n-doped layers. See the picture here. A small current entering the base is amplified to produce a large collector and emitter current. That is, when there is a positive potential difference measured from the emitter of an NPN transistor to its base, i.e., when the base is high relative to the emitter, as well as positive potential difference measured from the base to the collector, the transistor becomes active. In this on state, current flows between the collector and emitter of the transistor. There are three poles for the regions: base, B, emitter, E, and collector, C. They form two PN junctions, namely the base emitter junction and collector base junction. The arrows in the NPN mark here indicates the direction of the base emitter junction. The symbol of NPN is shown here. We consider two PN junctions with unilateral conductivity inside, which enables it a switch component. There are three working conditions for it: amplification, saturation, and cutoff. When the base emitter junction is forward biased and collector base junction reverse biased, the status of NPN is amplification. When both junctions are forward biased, it is saturation. When both are reverse biased, it is cutoff. As for forward and reverse bias mentioned here, to put it simple, when a positive voltage is added to the p-pole of a PN junction, the PN is electrified then, which is called forward biased. The opposite situation, which means the voltage is added to the N pole, is thus called reverse biased. Okay, now the experimental principle. The coil of the relay needs a large current, about 50 amperes, to make the relay closed, which general integrated circuits cannot provide. Therefore, we need a device to enlarge the current, which means a driver. In the experiment, we use an NPN to drive the relay. Connect the relay between the collector of the NPN and power. The coil is a load in the circuit. When 0 voltage is input at the base, the NPN is in cutoff state and there is no electricity passing through, so the relay is released. When a certain voltage is added, the NPN is saturated and some currents pass through the coil of the relay, so the armature and normally open contact closed. Thus, the LED connected is on. Okay, now let's build a circuit. Plug the NPN and relay on the breadboard. Connect a 1000 resistor at the base of the NPN. And then connect them to pin 8 of the SunFoundry Uno board. Connect a diode to the collector of the NPN and then connect to the armature of the relay. Connect the armature of the relay to 5 volts of the SunFoundry Uno board. The coil is connected to the armature at one end and the collector at the other. Then the normally open contact to a 220 ohm resistor and then the anode of an LED. Hook up the cathode of the LED to GND of the SunFoundry Uno board, and then the emitter of the NPN to GND. Now the circuit is completed. Open the IDE and type in your code. Based on the circuit we just built, the relay is connected with the NPN. So first connect the base of the NPN to pin 8 of the SunFoundry Uno board. We've learned constant integer before, which is to set relay pin as a constant integer. Then initialize relay pin as output with a pin mode function. Here we use digital write function to set relay pin as high. We know relay pin is connected to the base of the NPN, so when relay pin is high, the NPN is saturated. That means there are currents passing through the coil of the relay, and the armature and the normally open contact are closed, thus turning on the LED connected to the contact. Delay 1 second. Set relay pin as low. Accordingly, the relay is open and the LED will be turned off. Delay a second. With the loop function, the LED will keep lighting up and going out repeatedly and won't stop until it's powered off. Now check the results. Power the circuit. Then the normally open contact is closed and the LED connected lights up. 1 second later, the contact is opened and the LED goes out. Then 1 second later, it lights up. The LED is turned on and off repeatedly before the circuit is powered off. Now we've done the experiment. If you are still confused, go check the principle of driving a relay by NPN transistor. This experiment can be rather practically applicable. Relays have three major functions. First, acting as a switch. Second, protecting devices in the circuit when it's powered off due to overloading. Third, protection from malfunction power off. Relays are widely used in areas such as air conditioning, communications, and automobile. For any questions or comments, please visit our website www.sunfounder.com to leave a message. Thanks for watching. See you!